All right, so I'm in the building today, but not in the classroom. So I figured I'd record this so that we didn't lose another day. All right, so normal spot, we click on always start here. Our lesson is going to be found here. Click the yellow. This green here is a pixel art, which you can open and it can check your answers for you. So it's very helpful since I am not there. You type your answer in and it will show up as we go. But this is what I need you to click on. So go ahead and do that. Open it up, pause this as we're doing it as you need. It's going to look like this, right? Don't forget the SOHCAHTOA, our warm up, pause to do the warm up. Of course, you're not just going to watch me do it. All right, so we need to figure out what I'm trying to find this, right? I'm trying to find this X. Pick something better. Let's pick the highlighter so you can see what I'm talking about, right? I'm looking for this X here. And what side is that, right? Well, I know it is the hypotenuse, right? Why do I know that? It's the one across, not hip, the one across from the right angle, and it's the longest side, right? So I know that that one's a hypotenuse. It doesn't matter which angle I'm looking from. I'm going to use so it matches up with my SOHCAHTOA. But that's there. I know that it is the longest side. I know that it is across from the right angle, so it must be the hypotenuse. It doesn't matter what angle I'm looking from. But I do need to know what angle I'm looking from, right? I'm looking from this one right here. So that's my perspective, right? So that 18 units there, I need to figure out what side is it to that angle, right? The 18 is touching the 40. So that means it is the adjacent side, right? So we have that A. So if I scroll up a bit, sine, I would need my opposite in hypotenuse. I don't have that. Cosine, I need my adjacent in hypotenuse. Cool. That is what I'm going to use. Let me make this a little bigger. Okay, what color it is. All right. So what is it here? Well, the cosine of my angle 40 is going to equal to the adjacent side. That's the 18 over the X, which is slightly more annoying than we like to know, because that makes a two-step equation. But we've done this a few times, right? So we know if the X is on the bottom and the cosine 40 is here, I can swap those two. It can become X equals 18 over the cosine of 40. Why? Well, because we multiplied both sides by X and then divided both sides by the square root of 14. Excuse me. I just totally made that up. The cosine of 40, where did the square root of 14 come from? Your guess is as good as mine. Okay, so I am just going to swap it for right now to save time. Ask me, well, when you see me in the hallways, if you want to know more explanation on that, I'm sure you will stop me, right? All right, oops, I forgot. Let me just pause this here for a second. All right, I popped on over to Desmos. I'm going to do 18. Oops, of course, there's one to click right now. 18 divided by the cosine of 40. And there's my answer. So that side length that I didn't know, the hypotenuse is going to be 23. And since we have 497, we're going to, be lazy and go, well, 23.50, right? So that'll be good for that answer. So X, so this hypotenuse length now is 23, is that right? 0.50. Double check. You got it. Yes, 23.50. All right. So my thing. Oh yeah, that's just the answer. Okay, so there we are. What you're going to move on to next, part 2, if you want to determine the length of AB instead of AC, which trig ratio would you use, right? So we have to scroll up for a minute because that's so if we knew this side, right? It's saying if I knew this side instead and not this one over here, not this one, what would that be? Well, we would again look, how is that to the 40? What side is it in that perspective? Since it's across from it here, that's your opposite side, right? The opposite. So what would we use? Well, I'm pausing because I hope you all know that we would use the sign there, right? Because that's the opposite over hypotenuse. All right. Make sure I read the question correctly. Yes, ma'am, I did. All right. So make sure that you show all your work. Triangles may not be drawn to scale. Never trust our drawing. We just find pictures. Round to the nearest degree. Perfect. So we're not talking about, multiple decimal points here. We're just going to keep it cute and keep it short. In the right triangle, if you have two blanks, you can solve for either of the acute lengths, right? Well, here, what are we having now? We're going to have two sides. Let me get that in here. If we have two sides, you can solve for either of the acute angles, right? This is, trig for us right now is the relationship and the conversation between sides and angles. We have angles, we have sides. Okay, I know I talk too much even in a recording. All right, so first we need to identify, please fill in the blank ones, blank, either the opposite, adjacent, or hypotenuse. So identify which two sides we have. That's what we'll say. Identify, oops, I can't spell. Identify which two sides we have. Yes. Identify what trig functions to use, right? What trig functions. We're going to use sine, cosine, or tangent. Again, as always, we set up an equation and then we use the trig, inverse trig ratio. Yes, that is what we're going to use some context clues, right? We're using the inverse functions here. Right, because we're going to be solving for the angle. Before we were using it to do the sides, to find the sides, now we're undoing it, right? It's the flip of the coin, right? Inverse, opposites. All right, so here we have to identify what we know. I'm not going to do all of these. I'm going to do a couple of them for your understanding, right? So we were looking from this angle right here, right? I'm looking from theta. Don't worry, Greek letter, it's gorgeous, just love it. Okay, so what do we know? Well, we're looking, I see my right angle here and I look across from my right angle. If I'm looking up this way and I see that I do know my hypotenuse, cool, hypotenuse, cool, I already know what that is. And then according to theta, from theta's point of view, our 7 over here is opposite, right? So that's our opposite side. So if I forget, always can write it up here. So no. It doesn't want to let me do a nonsense word. Imagine that. SOHCAHTOA, right? So I have the O, I have the H, boom, boom. I'm going to be using sine here, right? We set up our thing. Well, the sine of what? Well, we don't know. Look, I can use it. All right. So sine theta is going to equal to our opposite over adjacent, right? And hypotenuse, opposite over hypotenuse. Our opposite side is 7 and our hypotenuse is 10, right? So cool, we're looking for what's in here. We're looking for this theta. We don't know what it is. That's what we're trying to get, right? So we have to undo, we have to do the inverse operation to get rid of this sign, right? We need to get it away from there. And it's just, we can use it in the calculator, right? It's wonderful. So you can see our numbers here. We have sine, cosine. I don't know if you can see my little mouse guy, but we have the sine, we have the cosine, we have the tangent, right? Those three buttons on your left-hand side. Well, oops, clear it all. Okay. Well, if we hit our function buttons, we have more, right? And right on top, and that often happens in calculators. They put them close together if they're inverse functions like this. So we have the sine and the inverse sine. That's what we're going to call it for now. There's other words, cosine and the inverse, tangent and its inverse, right? So what we need to do is find the inverse of 7 over 10, right? We're finding the inverse sine of, go back to main, 7 over 10. And our angle up there is 44 degrees. Okay, so oops, that was just our answer key. So we do our inverse sine. Can I use a little type now? Let's find out. Oop, nope, it did that the other way. So right, of 7 over 10, right? Oops, I did 7 over 10, right? And that gave us an answer. Oops. Yeah, I didn't do this formatting right. I'm just really sorry, y'all. -1. And then I need this to go down 7 over 10. That's doing weird stuff. Now, if you mistype that, like do not, but obviously I have trouble with it too, right? And our answer for that, again, is 44 degrees. All right. There you are, 44, and that's fine, perfect. All right, so that angle, move this guy here, angle theta up here is 44 degrees. Okay, let's try a few more, and then you can give a few on your own. All right, so we have this angle up here. We're looking for how many degrees X is. I don't know my hypotenuse, right? My hypotenuse is not here. So if I look at my SOHCAHTOA, the only one that doesn't use hypotenuse, we're going to be doing some tangents here, right? So our equation, again, oops, I didn't mean to do that. I meant to do this one. Our equation is the tangent of X, right, is going to equal to its opposite side. So I need to go across. So it's opposite side because toe, O first. So that's going to be my 8 over my adjacent side 4, right? I have to undo my tangent. I'm going to use my inverse tangent, right? So I'm going to go function, get this guy, and back to main. And it was 8 over 4. Put that in there. And there we are. That is going to be 63.4. So round it to 63 degrees. All right. So X is going to be 63. Why am I trying to do this? I should have typed it, but that's okay. All right. A few more just to make sure that we're getting it. We've got our cross. Again, we have no hypotenuse, so we're using the tangent. Right, so the tangent of our angle that I have no idea because I covered it, tangent of X is going to be my opposite side. So I have to go across here to 9. So it's going to equal 9 over 7. Right. Again, just hit enter. We're going to keep going on it so we can see what it is. Tangent of course, I talked too much, so I already forgot. 9 over 7. Tangent of 9 over 7. Bam, 52 degrees. All right, so that's how we do these ones. I guess I'll do one more because I said I would. So X equals 53. 52. Always check your work. 52 degrees. All right, and then we have one more here. We've got our angle. We do have the hypotenuse this time, right? We have our H. So I'm not going to use tangent. And this 5 is touching, so that must be my A. So so I'm going to use my cosine, right? Because of ka. Okay, so the cosine of our angle that we don't know, I'm just going to write X, whatever, is going to equal to our adjacent side, that 5 over 12, right? I got to undo this cosine. I'm trying to get rid of it, right? So this is if we do it over here. So hit enter, the cosine, and of course I talk too much, 5 over 12. And there we are. So 65 degrees. So that angle up here, it doesn't matter what it looks like. X is going to be 65 degrees. All right, so give that a shot. It's just some calculator play. Use Desmos, use the scientific calculator. It's the one that says scientific explicitly. It just is a lot easier for you, but everything is there for you. All right, so see you around.